So in this video, we're going to look at questions involving the intersection of a linear line, basically a linear curve is a line, with a parabola. And basically this is a three-step problem, right? So if we have a parabola like this, then we have sort of like three cases. One case is that we have 2 points of intersection. The other case, that is case 1. The other case is that we only have 1 point of intersection. So if a line only touches or only intersects with the parabola at exactly 1 point and then never again, this is also known as a line tangent to the parabola. So this is case 2. And it's also possible that the line never intersects the parabola at all. So maybe it never touches the parabola. So those are three cases. And how we are going to solve it is, 1, we form a simultaneous equation. So we solve simultaneous equations and we check discriminant. So those are two techniques that we will be using to solve these type of questions, right? And that is about it. So basically things will be clearer when we start doing some of the questions here. All right, so we've done some of the problems before actually. So this is just like special case, more additional problems, mostly involving the idea of the discriminant. All right, so find the values of k for which the line. So we have, for question 1, we have a line. And the line has the equation y is equal to kx plus 1. Is tangent to the curve this line. So y is equal to x squared minus 7x plus 1. Plus 2, sorry. All right, so we have two equations. Equation 1 and equation 2. Let's substitute equation 1 into equation 2. Because y is already given, I can say that kx plus 1 is equal to x squared minus 7x plus 2. And we want is a tangent. So we only want 1 point of intersection. Right? If our straight line is tangent to the parabola, then we only have 1 point of intersection. So now we can rewrite this equation. Let's take the two terms here to our right-hand side. So we will get x squared minus 7x minus kx, right? 2, and then if we take 1 to the other side, we get minus 1. So we get plus 1. 2 minus 1 is just 1, equals to 0. And now our middle term, we can write it as 7 plus k x plus 1. Equals to 0. So I factored out the negative x. So I factored out a minus sign. So I get 7 plus k. So if I put the minus sign inside, I get minus 7 minus k, right? And then I factored out an x. So overall, I still have whatever I have here. So it's the same equation. So I just write it like this. So now, because we only want 1 point of intersection, this quadratic equation must only have one real root. And if you remember, the discriminant b squared minus 4ac must be equal to 0 for this condition. So now we just use that condition. Minus 7 plus k squared minus 4, a is just 1, and c is just 1, should equal to 0. So basically we have 7 plus k squared should equal to 4, right? 4 times 1 is 4. If I add 4 on both sides, I get this equation. So now 7 plus k is equal to plus or minus 2. If 7 plus k is positive 2, if I square positive 2, I get 4. If 7 plus k is negative 2, if I square negative 2 here, I still get 4. So positive and negative 2 both are valid answers. So now 7 plus k, if that is 2, then k is equal to negative 5, right? So if you solve this, you get k is equal to minus 5. And if 7 plus k is equal to negative 2, then k is equal to negative 9. So those are your two values of k for which your straight line will be a tangent to your parabola. So minus 5 and minus 9. Those are the values of k. All right, so that's how we're going to solve most of the question in this chapter, in this topic. All right. So part 2, find the values of k for which the x-axis is a tangent to the curve. So x-axis, what equation represents the x-axis? Well, x-axis is the line y is equal to 0, right? Your x-axis looks like this here, and that corresponds to y is equal to 0. So we are going to use this information. If I substitute y is equal to 0 into this equation, I get the equation x squared minus k plus 3x plus 3k plus 4 is equal to 0, right? And then it's a tangent. So again, I want b squared minus 4ac to be 0. The discriminant must be equal to 0. And now we can just solve this. If I will have k plus 3 whole squared, or just, you can take minus sign as well and whole squared, but you can separate minus 1 squared. That just gives you 1. So you only have, if you simplify everything, you'll have k plus 3 squared left for b squared. Minus 4, a is just 1, c is 3k plus 4. That is equal to 0. And now we can expand and simplify. So I'll get k squared plus 6k plus 9. That is what you get when you expand the bracket here, minus 12k plus 16. And now if I simplify, I have k squared minus 6k, 9 minus 16. That is minus 7, right? All right, and I can factorize this. So I believe I will get minus 7 plus 1 is equal to 0. And therefore, your two values of k are k is 7 and k is negative 1. So you can sort of factorize slowly based on your idea, based on what we have done in the previous videos, but this is going to be your solution. If you factorize the equation, you get this. So your solutions are 7 and minus 1. So, all right, we are done with 2. Question 3. Find the value of k for which this line is a tangent to the curve. Again, you use what you have. So if I know x plus ky is equal to 12, then I know that, hey, ky is just 12 minus x, and y is 1 over k, 12 minus x. And I'm going to substitute this information here, because y is just 1 over k, 12 minus x, and y is equal to 5 over x minus 2. So now if I multiply by k on both sides, right? I multiply by k, I multiply by k, this cancels out. So I have 12 minus x is equal to 5k divided by x minus 2. And if I multiply by x minus 2 on both sides, I get 5k. And this is assuming x does not equal to 2. If x is equal to 2, then our denominator is 0, and we cannot have a 0 denominator. And now we can just expand this bracket, right? I have 12x minus 24 minus x squared plus 2x is equal to 5x. So when I simplify, I get minus x squared plus 14x minus 24 is equal to 5x. And if I subtract 5x on both sides, I get minus x squared plus 9x minus 24 is equal to 0. All right. If I did everything correctly, this should be the equation that I get. Let me see. I think it should be all right. So if I multiply by a negative 1, I get x squared minus 9x plus 24 should be equal to 0, right? So I just multiplied by negative 1 to this equation. And we want the line to be a tangent to the curve. Oh, this is k, that's why. All right, that's why I was so confused. This is k, my bad. My apologies. So this is k. All right, sorry about that. And we get minus x squared plus 14x minus 24 minus 5k. This is going to be 0. So minus x squared plus 14x minus, if I factor out the negative sign, I get 24 plus 5k is equal to 0. So I have A, B, and C. So B squared, 14 squared, minus 4. A is negative 1. C is negative 24 plus 5k is equal to 0. right? So minus minus, one negative sign cancels out and gives me positive in front. So I still have minus 4 here. So 14 squared is 196. 196 minus 4 times 24 plus 5k. And I can divide by 4. So 196 divided by 4 is 49 minus 24 plus 5k. So using this, I know minus 5k is 49 minus 24. That is 25. So minus 5k plus 25 is equal to 0 if I simplify this, and you can get k is equal to 5. So your k is equal to 5 gives you your solution. So if k is equal to 5, then this line is a tangent to the curve. All right. So basically, you want to use the information from equation 1, you substitute it into equation 2, and then based on the condition given, you want to check the discriminant. So that is the idea here. All right. So question 4. You have this line is a tangent to the curve, right? So we can just substitute the information. X squared plus 2xy minus 20 is equal to 0, and we know what y is. So x squared plus 2x, y is just k minus 3x. Minus 20 is equal to 0. And now we can simplify this. X squared plus 2x, k minus 6x squared, right? Minus 20 is equal to 0. And x squared minus 6x squared, that is minus 5x squared plus 2kx, that is my second term, minus 20 is equal to 0. And we know that this line, so it's tangent to the curve. So our discriminant, again, only one intersection, that means we only have one repeated root, that means b squared minus 4ac has to be 0. So b is 2k squared minus 4, a is negative 5, c is negative 20. 4k squared minus 4 times negative 5 times negative 20, that's positive 100. And I can divide by 4. So I just divided both sides by 4. I get this equation. So k squared is 100. So we know that k squared is equal to 100. So k is plus or minus 10, right? 10 squared, positive 10 squared is 100, negative 10 squared is also 100. All right, so we have two found or possible values of k. We just want to substitute this here for part B, because it says for each of these values of k, find the coordinates of the point of contact of the tangent with the curve. All right, so we just substitute k here. So for k is positive 10, we have minus 5x squared plus 20x minus 20 is equal to 0. If I divide each term by negative 5, I get x squared minus 4x plus 4 is equal to 0. And this is just x minus 2 whole squared. So therefore, x is positive 2 in this case, right? And if x is 2, then what is y? So y is, remember, 10, k is positive 10, so 10. So y is k minus 3x. K minus 3x, right? So we can use the linear equation because they're intersecting, so it has to be the same point in both curves, right? If it's an intersection. So 10 minus 3, and then x is positive 2. So 10 minus 6, so 4. So 2 comma 4. If k is positive 10, then the point of intersection is 2 comma 4. If k is negative 10, then we have the equation. I have to substitute it here. Minus 5x squared minus 20x minus 20 is equal to 0. And if I divide everything by negative 5, I get x squared plus 4x plus 4. And that is just x minus 2 x plus 2 whole squared. And I get x is equal to negative 2. And now y is just k minus 3x. K is just negative 10 minus 3, x is negative 2. So it's negative 10 plus 6 is negative 4. So the intersection is negative 2 comma negative 4. So you want to remember which value of k you are using, and you want to perform the calculations accordingly. So these are our points of intersection. So the coordinates of the point of contact of the tangent with the curve are just these points corresponding to their respective values of k. So we are done with part 4. All right. find the values of m for which this line is a tangent to this curve. So we just want to substitute the value of y into this curve, right? mx plus 6 is equal to x squared minus 4x plus 7. And we can take both terms to my right hand side. So I will get x squared minus 4x minus mx, 6 minus 6, so plus 7 minus 6 is just plus 1 equals to 0. And I can factor out a minus x. So I'll get 4 plus m x plus 1 is equal to 0. So this equation is the same as this equation. Now b squared, negative 4 plus m squared is the same as just 4 plus m squared, right? B squared minus 4, a is just 1, c is just 1 is equal to 0. So 4 plus m squared is equal to 4, right? This just simplifies to 4. And if I add 4 on both sides, I get this. So 4 plus m is equal to plus or minus 2. Therefore, if 4 plus m is equal to positive 2, m is equal to negative 2. If 4 plus m is equal to negative 2, m is equal to negative 6. So negative 6 and 2, that is your answer. And it says, find the coordinates of the point where the line touches the curve. So you want to substitute this back into your here. So if m is equal, right? If m is equal to, let's say, negative 2, m negative 2, then this equation turns into x squared minus 4 minus 2. That is 2x plus 1, right? So x squared minus 2x plus 1 is equal to 0. And this is just x minus 1 whole squared. So therefore, your x value is 1. And what is your corresponding y value? Well, you just use this equation. So y is equal to mx plus 6 is equal to m is negative 2, x is equal to 1 plus 6. So it's 4. So 1 comma 4 is your point of intersection. And if m is equal to negative 6, then you just substitute it into this equation. X squared, 4 minus 6, so you'll get plus 2x plus 1 if you simplify, right? 4 minus 6 here gives you negative 2. Minus of minus 2 gives you positive 2. And this is just x plus 1 whole squared. So therefore, x is just negative 1. And if so your y is equal to negative 6, that is your m value. X is negative 1 plus 6. So that is just 12. So your point of intersection is negative 1 comma 12. Negative 1 comma 12. All right, so that is your answer. Question 6. Find the set of values of k for which this line intersects this curve at two distinct points. So we want to substitute this information here. So 2x minus 1, that is y, is equal to x squared plus kx plus 3. And now if I send these terms to my right-hand side, I get x squared plus kx minus 2x plus 4 equals to 0, right? I'm not sending the terms. I'm adding 1 and subtracting 2x on both sides. So I get x squared plus k minus 2x plus 4 is equal to 0. So this is the equation, and I want at two distinct points of intersection. So b squared minus 4ac for this quadratic equation must be positive, right? Discriminant bigger than 0 gives me 2 points of intersection. So there must be two distinct roots for this equation. So k minus 2 whole squared minus 4, a is just 1, c is positive 4. So k minus 2 squared minus 16 bigger than 0, right? So k minus 2 squared bigger than 16. Now there is something that you need to be careful about. If k, so what are possible values of k minus 2? If k minus 2 is bigger than 4, right? Then k minus 2 is positive. So if I multiply by k minus 2, so if my k minus 2, whatever this value is, if it's bigger than 4, then of course the square of this will be bigger than 16, right? 4 squared is 16. So this is a positive value. So I don't need to worry about this. K minus 2 is positive. If I square this, the square of it is going to be 16. So that's one possible solution here. But k minus 2 can also be less than negative 4. Why? Because whatever number is less than negative 4, if I square that, that is also going to be bigger than 16, right? For example, negative 5 is less than negative 4, but negative 5 squared, whole squared, is 25, which is bigger than 16. So you have two outputs, especially if you have a square term. So the idea is that if you say a squared is an inequality is bigger than, say, b squared, then it follows that a can be bigger than b. That is one idea. Or a can be less than minus b. And as long as this is satisfied, the inequality will still hold. If you square a here, then positive a squared, so this is assuming b is positive, right? So positive a squared is going to be bigger than b, but if a is less than negative b, squaring that will also give you something that is bigger than b squared. So using this idea, if any number bigger than 4 squared gives me something that is bigger than 16. Any number less than negative 4 squared also gives me something bigger than 16. So k is, if I add 2, is bigger than 6. K is less than negative 2. So yeah, that is going to be your the range of solutions is going to be, the set of values is of k is going to be greater than 6 or less than negative 2. All right. So we move on to 7. So find the set of values of k for which this line intersects the curve at two distinct points. So I can just substitute the information here, right? From this equation, I get x is equal to k minus 2y. So that is the information I get from the first equation. And my second equation is xy is equal to 6. So I can say k minus 2y times y is equal to 6. So ky minus 2y squared is equal to 6. If I take all my terms to my right-hand side, I get 2y squared minus ky plus 6 is equal to 0. And now we want intersection at two distinct points. So the discriminant, which is minus k squared minus b squared minus 4, a is 2, c is 16. This must be positive, right? So k squared minus 4 2s are 8, 6 8s are 48. I believe. All right. So k squared is bigger than 48. So k can be bigger than square root of 48, or k can be less than negative square root of 48. So this is the same idea that we have been used before. Anything, if k, as long as k is bigger than square root of 48, k squared will be bigger than 48. If k is less than negative square root of 48, squaring this also gives you something that is bigger than 48. So k is bigger than square root of 48. 48 is 16 times 3, so 4 root 3, right? Or k is less than negative 4 root 3. That is going to be your two solutions. So k bigger than 4 root 3 and k less than negative 4 root 3. So that is your solution for 7. All right. Find the set of values of k for which this line cuts the curve at two distinct points. You can just substitute it here. So k minus x is equal to 5 minus 3x minus x squared. And we can simplify. So if I bring all the terms here to my left-hand side, I get x squared minus x plus 3x, right? So I'll get plus 2x, and then I have plus k minus 5. So if you bring all the terms to your left-hand side, you get this equation. And again, two distinct points of intersection means the discriminant of this equation. So 2 squared minus 4, a is 1, c is k minus 5, must be bigger than 0. So 4 minus 4 times k minus 5 must be bigger than 0. And because 4 is positive, we can divide by 4 on both sides without the fear of having to change our inequality. So minus k plus 1 plus 5 is 6, is bigger than 0. So k is less than 6, right? If I add k on both sides. So that should be your answer. K less than 6. All right. So that is the solution for 8. K is less than 6. 9. Find the set of values of m for which the line here does not meet the curve. So first of all, we would just want to set the two equations to be equal. So mx plus 5 is y, which is x squared minus x plus 6, right? So I just substitute y here. And now I bring everything to one side. So x squared minus x minus mx, and then plus 6 minus 5, that is plus 1 equals to 0. And x squared, if I factor out minus 1, m plus 1x plus 1 is equal to 0. So I just factor out a negative 1 and then x here. So it should be the same expression as the above one. And now b squared, m plus 1 squared minus 4, a is 1, c is 1. That should be, your discriminant must be negative. If you do not want a solution, if you do not want your curves to meet, then you basically want your discriminant to be negative, right? So m plus 1 squared minus 4 must be less than 0. M plus 1 squared must be less than 4. Therefore, m plus 1, it can be less than 2. So if you have this condition, now it's not greater anymore, right? So if you have a squared less than b squared, then a is bounded as follows. So as long as a is between negative b and positive b, the square will be less than b squared. So this is the idea that we are going to use. And you can sort of think why this is true. But m plus 1 is less than 2 and bigger than negative 2. So m is between 1 and negative 3. So that is your solution. If you do not want the curves to meet, this inequality must be true. All right. Question 10. So we want the set of values of k for which this line does not meet this curve. So 2x minus 10, we just want to set it equal first. And then we want to sort of work with the discriminant. So if I send everything to one side, I get x squared minus 8x plus 10 plus k, right? That is equal to 0. And again, discriminant, minus 8 squared, b squared minus 4, a is just 1, c is k plus 10. The discriminant, if you do not want your curves to meet, has to be negative, less than 0. So 64 minus 4k plus 10. And because I can divide by positive 4 without worries, I get 16 minus 10 is less than 0, right? So I just divided by 4, and that does not, I don't have to change my inequalities. 16 is k plus 10, right? I just sent the whole k plus 10 here, and then if I subtract 10, I get that k is bigger than 6. So that should be your answer. K bigger than 6 should be your answer to 10. Yeah. All right. Find the set of values of k for which this line is a tangent to this curve. And it's the same idea. We can substitute y inside, right? X squared plus y is just kx plus 6 squared minus 10x plus 8y is kx plus 6 is equal to 84. All right, so now we can simplify this. X squared plus kx squared plus 6. If I square this, if you try to square it, you get x squared, k squared x squared plus 12kx plus 36 minus 10x plus 8kx plus 48 is equal to 84. So now let me collect my x squared terms. So that is 1 plus k squared x squared. So you can think it through why this is going to be my x squared terms. Let me collect my x terms. I have 12kx plus 8x, right? So that is 20kx. 12kx plus 8kx is 20kx minus 10x. So I can write this as 20k minus 10x plus. And finally, I need to worry about my constant terms, right? So I have 36, I have 48. 36 plus 48. That is 84. So So I have plus 84 is equal to 84. If I subtract 84 on both sides, I'm going to get 0, and the 84 on my left-hand side is going to cancel out. So I have this equation. And basically what I want is my b squared minus 4ac. It says tangent, so I want this to be equal to 0. Discriminant should be equal to 0 if I want it to be tangent to the curve, right? Only one repeated root or one point of intersection. So b is this expression, 20k minus 10 squared. Well, c is just 0, right? I don't have any c, so this second term just collapses to 0. And now I want 20k minus 10 should be 0. Only 0 squared will give me 0. So 20k is equal to 10, k is equal to 1 by 2. So that is your answer for 11. Question 12. The line y is equal to mx plus c is tangent to this curve. So y, again, you can just substitute your y value here. Mx plus c is equal to x squared minus 4x plus 4. And it says prove that this. Okay, it's tangent to the curve. So we just want to write everything as one side, right? So x squared minus 4x minus mx plus 4 minus c. If I subtract mx on both sides and if I subtract c on both sides, I get this equation. I can write this as x squared. I can subtract a minus, so I get 4x plus m, right? 4x plus mx if I subtract the negative sign for my x terms. And I can actually write this x outside, because it's basically, I'm saying that x multiplies both terms inside. And 4 minus c. And now, b squared minus 4ac should be equal to 0, right? If I want it to be tangent to the curve. So b is this expression. So minus 4 plus m squared minus 4, a is 1, c is 4 minus c is equal to 0. So now I can just simplify this. This is like saying I have minus 1 squared and I have 4 plus m squared, right? I have a minus 1 outside. So two things multiplied together, whole squared, you square the first thing times square of the second thing. Minus, you have 4 minus c. Alright, so this is just 1. Positive 1 times anything is just that thing. So I have 16 plus 8m. 4 times m is 4m times 2 is 8m plus m squared minus 16 plus 4c. So if you simplify everything here, you get this equation. So these cancels out. And finally, I get m squared plus 8m plus 4c is equal to 0. And that is exactly what they want us to show. So that is how you show it. So I know I'm going a bit fast here, but based on everything, all the videos that we have covered and all the questions that we have done. So mostly I'm giving you the ideas to solve these questions. And finally, we have this question. The line is tangent to this curve. So again, it's a proof that question. So you just substitute this here. Ax squared plus b on y is just mx plus c squared is equal to c, right? by squared. So y, I just substitute it in and I square it, equals to c. So ax squared plus b, if I simplify whatever, if I square everything, I get m squared x squared plus 2mcx plus c squared. And you can sort of do it slowly if you think this is too fast, but this is equal to c. And now I can start simplifying. Ax squared plus bm squared x squared plus 2mbcx plus bc squared is equal to c. And now I can write this as a plus bm squared times x squared. I collect my x terms. I mbcx, right? X squared x, and now my constant term is just bc squared minus c if I subtract c on both sides. And this is equal to 0. And now, because we want to find tangent, only one point of intersection, that means my discriminant, b squared minus 4, a is this expression, c is this expression. That should be equal to 0. Alright, so if I square this, I get 4m squared b squared c squared minus 4. If I simplify everything here, I get abc squared minus AC plus B squared M squared C squared. I know it's a bit funny as well. Minus BCM squared. That is equal to 0. And now if I divide by 4 on both sides, I have M squared B squared C squared minus ABC squared. I have to distribute this negative sign, right? Plus AC minus B squared M squared C squared plus BCM squared. I just distribute this negative sign inside my brackets. So this and this, I believe, should cancel out. M squared B squared C squared minus M squared B squared C squared. So I have finally, if I send this to the other side, I have ABC squared is equal to AC plus BCM squared. And I can cancel out a C here. So ABC C squared is just ABC times C. And I can factorize a C outside. I have A plus BM squared. So this C cancels out with this C. And let me look at what we're trying to prove here. So I want to isolate M squared, right? So ABC is equal to A plus BM squared. So ABC minus A is equal to BM squared. And finally, M squared is just ABC minus A over B, which is exactly what they want here. And that is it. That is how you prove this expression. Alright, so that is all for chapter 3, quadratic equations, and we'll move on to functions next.